Welcome back to the Deep Dive. We're here to take a complex stack of sources and give you the knowledge you need, turning information overload into actionable insight.
And today, we were talking about a really fundamental shift in how we think about AI.
We really are. We're moving past the AI you just talked to,
Yeah.
the simple query response chatbot model,
Yeah.
and getting into the AI that actively thinks.
And plans and executes tasks, all on its own.
Oh.
We are talking about true AI agents.
It's the agentic leap, right?
That's the term, yeah. This is what allows these systems to not just spit out text, but to actually reason, to form these multi-step plans and then act on them in the real world.
Okay.
So our sources today, they really define what these agents are. They break down their core components and, they get into the key architectural patterns driving them.
And crucially, the new standardized protocols that are making it all work at scale.
Exactly, making it reliable.
So let's unpack this. When most people think of an LLM, a large language model, they think of something incredibly smart, but, well, passive.
It is. It's fundamentally a static system. It's kind of closed off, operating only on the huge amount of knowledge it was trained on months or even years ago.
It's a brain in a jar.
A very powerful brain in a jar, yes. And look, many of you listening are probably familiar with RAG retrieval augmented generation.
Right, which feeds the LLM fresh external knowledge.
It does. But even with RAG, you still often need a human in the loop to kick off the query and then check the result.
The agent, then, is that next big evolutionary step. It's not just responding, it's the active orchestrator.
That's the perfect way to put it. It takes the LLM, the brain, and turns it into a decision maker, one that can look at a goal, figure out a path, pick the right tools.
And just start executing on its own.
That autonomy changes absolutely everything. I mean, we saw a great example in the sources, this whole research report generation scenario.
Okay.
If you try to do that with a standard LLM, you are the control loop. You ask for a report, it gives you some general facts, then you realize you need sources.
So you ask it to search, then you realize the sources are old, so you have to refine the query again.
It's this manual, iterative back and forth. You're steering every single step of the way.
Right. But a multi-agent system, that's different.
It completely replaces that human intervention. The sources laid out this really elegant chain of specialized agents. First, you have a research agent. It takes the query and just goes searching databases, news archives, whatever it needs.
And that output doesn't go straight to the user.
No, of course not. It goes to a filtering agent, which might prioritize sources by how new they are or their citation count, something to score relevance.
So you're filtering out the noise before the real work even begins. Smart.
Exactly. Then those validated sources move to a summarization agent. It pulls out the key insights. Maybe it focuses on conflicting data points.
And finally,
A formatting agent takes all that raw intelligence and structures it into a professional report. And the really cool part is that they can self-correct. The formatting agent might send a note back to the summarization agent saying, hey, this section is missing a date, and it kicks off a little mini loop to fix it, all without a human.
that is genuinely autonomous production. Okay, so to build that kind of robust system, the sources point to 6. Let's call them essential building blocks.
Yeah, these are the design principles, the things that let an agent reason, plan, and importantly, correct itself.
Let's start with the first 2. Role and focus.
So role-playing is maybe the simplest but most powerful trick. If you just tell an agent you're an assistant, you get vague, generic output.
Right.
But if you give it a very specific persona, like you are a senior contract lawyer specializing in intellectual property, its whole reasoning process shifts.
It's looking at the world through that specific lens.
Precisely, and the output is just so much sharper, more relevant.
Okay, that builds right into the next one. Focus tasks. If specialization is so good, why not just build one giant agent that knows everything?
It's a great question. And it comes down to a trade-off between general intelligence and rock-solid reliability. If you give one agent too many jobs, like a marketing agent that has to do messaging, pricing, and server maintenance, you get cognitive overload. It just gets confused.
Which leads to hallucinations.
It dramatically increases the chance of hallucinations, yes. So the idea is to trade that general ability for absolute reliability in one very narrow domain.
I see. So you trade flexibility for reliability, which is what you need for an autonomous system.
Yeah.
Okay, block 3. Tools.
If the LLM is the brain, then tools are its arms and legs. They're the APIs, the code interpreters, the databases it uses to actually interact with the world.
This is how it does a real-time web search or checks a stock price.
Exactly. But a key principle from the sources is that you should only give an agent the tools it absolutely needs.
Really? Wouldn't more tools always be better?
It feels like it should be, but no. Giving, say, a code debugger agent access to a currency converter API just creates noise.
The agent wastes time trying to figure out why it has that tool.
It slows down the process and makes it more likely to pick the wrong tool for the job.
Okay, so you're basically replacing the LLM's old static knowledge with a live, dedicated connection. The currency converter example made that very clear.
It's the perfect example. An LLM might know the exchange rate from 2 years ago. But if you give your currency analyst agent a custom tool that hits a live financial API,
it suddenly has real-world dynamic data. It can do actual analysis.
Something a static LLM just can't do alone.
Which is incredibly powerful. Okay, moving to the fourth block. If specialization is good for one agent, cooperation seems like the logical next step for a team of them.
Absolutely. I mean, think about any complex project in the real world. No one person does every single step.
Right.
In that financial analysis system, you'd have one agent gathering data, another assessing risk, a third writing the strategy. They delegate, they share insights, and that collaboration acts like a built-in fact checker.
A self-correcting feedback loop.
Exactly.
And since these systems are acting on their own, you need some boundaries. Block 5, guardrails.
Guardrails are your safety net. They are absolutely essential. An agent can get stuck in a loop, or it could try to misuse an expensive API key or, generate something harmful.
So guardrails are just constraints.
They're constraints. A hard limit on how many times a tool can be used, a filter on the output, a mandatory checkpoint where it has to, say, cross-reference a cited law against an up-to-date database. They keep the system from running wild.
And finally, the piece that makes it all feel like a real coworker instead of a script. Memory. Why is this so critical?
Because without memory, the agent has amnesia. It resets to 0 after every single task.
The sources had that perfect, frustrating example. You tell it your favorite color in the morning.
And in the afternoon, you ask it, and it says, you haven't told me. It just feels broken.
It's a brutal user experience, yeah.
Memory lets the agent hold on to context. It lets it improve over time. And it's not a feature of the LLM itself. It's a whole design system built on top.
And there are different types of memory we need to think about.
That's right. At the simplest level, you have short-term memory. That's basically the context window, what happened in this one conversation.
Okay.
But then you have long-term memory, which is what persists across sessions. And that's where it gets really interesting and, frankly, complex.
And long-term memory itself is broken down, right?
It is. You have semantic memory, which is for facts and knowledge, things it learns. Then you have episodic memory, which is memory of past experiences, recalling how it solved a similar problem before.
Which is key for improvement.
It's critical. And finally, procedural memory, which is about learning how to do things better, storing refined instructions, that sort of thing.
And for a business, you need entity memory.
Oh, absolutely. That's for storing focused information on specific subjects. For a CRM agent, that's your customer details, their preferences, their purchase history. It creates a system that's not just smart, but contextually aware of you.
Okay, that covers the building blocks. Now that we have the ingredients, let's talk about the engine. The sources mention a few design patterns, but the big one, the one powering frameworks like Crew AI, is React.
Reason and act.
Reason and act.
It's so elegant because it forces a structured process that mimics how people actually think. It combines that internal monologue, the chain of thought reasoning, with the external action of using a tool.
And it has this beautifully simple loop: thought, action, observation.
It's a discipline, really. The agent has to first state its thought process, what it's about to do and why. Then it takes the action. Then it's forced to record the result of that action as an observation, and it just repeats that cycle.
Okay, let's use that population calculation example from the sources. What is the population of India plus the population of Japan?
Right. So the agent gets the prompt. Step 1 is a thought. Okay, I need to get the final answer, but first I need the population of India. I'll use the lookup population tool for that.
So it's acknowledging what it doesn't know.
Exactly. Step 2 is the action. It runs look population, India, the tool goes off, hits an API.
And step 3, the number comes back, it gets injected into the context as an observation.
And that's the key. It's verifiable data, not just generated text. Then the loop restarts. A new thought, okay, I have India, now I need Japan. It repeats the whole cycle for Japan.
And once it has both numbers.
Final thought. I have both data points. I need to do the math. Final action, Mashwent. 50000.
What's so fascinating is that structure. It cleanly separates the brain, the LLM thinking, from the limbs, the tools doing the work.
Which gives you transparency and reliability. You can look at that log of thoughts and actions and see exactly why the agent did what it did. It's not a black box.
Which is paramount. But once you have thousands of these specialized agents all running around, they all need to talk to each other. And historically, that's been a total mess.
Like a fragmented mess, yeah. Every framework had its own proprietary way of doing things.
So for these systems to be practical, we need standards. And the sources highlight that the industry is thankfully starting to converge on 3 key protocols.
Think of them as layers of a stack, each one solving a different problem. You've got tool chaos, agent isolation, and the black box user experience.
Okay, let's start with tool chaos. That's the Model Context Protocol, or MCP.
MCP standardizes agent-to-tool communication. It's the foundation. It defines the exact format for how an agent finds a tool, understands what it does, and calls it.
So it doesn't matter if my tool is written in Python or Rust, any agent can use it.
Any agent that speaks MCP, it makes tools universally plug and play.
Okay, that's huge. Next problem, agent isolation. How do we get them to collaborate? That's A2A, these agent-to-agent protocol.
A2A standardizes multi-agent coordination. It's how they talk, delegate tasks, and share context without, having to share their entire internal memory or prompt.
How does that work?
The elegant part is that agents publish an agent card. It's like a business card that says, here's what I can do, and here's the information I need to do it.
So my research agent can just scan the network, find the summarization agent's card, and use A2A to hand off the task cleanly.
Exactly. It lets them form dynamic, self-assembling teams. But none of that matters if the user can't see what's happening. That's the third layer. AGUI.
The Agent User Interaction Protocol.
This is critical for anyone building an actual application. It solves that black box problem.
By standardizing the real-time updates to the front end.
Right. Instead of a loading spinner for 5 minutes, AGUI standardizes the streaming of specific events.
Like what kind of events?
Things like text token streaming, so you can see the text as it's generated. But more importantly, you get events like tool call start and tool call end.
Ah, so the user can literally see, okay, now it's looking up the population, and okay, it got the answer.
It lets the user see the agent thinking and working. And the protocol also standardizes things like how a user can interrupt the process mid-run.
So these 3 protocols stacked together, they're the plumbing that makes the whole ecosystem practical.
Autonomous, coordinated, and transparent action. That's the goal.
Okay, let's pivot to that last layer of sophistication, making sure the core instructions are perfect. We all know prompt engineering is key, but tweaking system prompts by hand. It's slow, it doesn't scale.
It's basically guesswork, and what works for one model might fail on another. The solution now is automated optimization using toolkits like OPIC.
So we're having AI optimize its own instructions. How does that loop actually work?
A developer starts with, a decent first draft prompt and, crucially, an evaluation data set, a list of inputs and the known correct outputs.
A ground truth.
A ground truth. Then you bring in another powerful model, a meta-prompt optimizer. It looks at the agent's prompt, runs it against the data set, and sees where it fails.
It's acting as a critic.
It's a metacritic, exactly. It reasons about why the prompt led to a failure and then proposes a refinement. Maybe if we rephrase this instruction, it will be clearer.
And then it tests the new prompt against the data set and scores it.
And it just keeps doing that over and over. It's basically running thousands of tiny A/B tests on its own instructions until it finds the version that gets the highest score.
So it establishes a baseline and just relentlessly iterates to find the optimal prompt.
It removes the human guesswork and can dramatically improve the reliability of the agent's core behavior.
Which brings us full circle. So for you, the learner, what we've really covered here is the fundamental architecture of autonomy.
Right. We've gone from the simple responder to the orchestrator. We've looked at the 6 building blocks: role, focus, tools, cooperation, guardrails, memory.
And the react pattern that drives that transparent, step-by-step decision-making.
Understanding these pieces means you understand the design philosophy behind real agency. You can look at an AI product now and see why some feel like powerful partners and others just feel like one-shot chats.
If you see a system taking multiple steps, explaining its work, that's the react loop in action, with specialized tools and memory. And here's where it gets really interesting, connecting it all back to those standards. The convergence on AGUI for user interaction and A2A for collaboration. It suggests a pretty radical shift in how we're going to work.
We are definitely leaving the era of interacting with a single monolithic bot.
Right. If the plumbing is standardized, the software can handle this incredible complexity behind the scenes. So what happens when every complex task you kick off, drafting a market report, triaging customer support, what happens when that's handled by a sophisticated, coordinated, and completely transparent AI team?
A team of specialized coworkers.
Whose thought process and handoffs you can literally watch happen in real time in the app. That's the future these protocols are building right now.